Okay, we're going to solve a grams to grams problem now. Now these problems are the big problems, okay? They're going to involve 3 conversion factors. So don't get scared. They tend to be a little bit on the bigger side. So you are now forewarned, okay? So step 1, you're going to need a periodic table. And that periodic table is going to help you go from grams of A to moles of A. All right, so once you have the molar mass or the formula mass of your first substance, right, which is the given information, and it tells you like 200 grams of this or 100 grams of this, that's the first step. Okay, so find that substance and find the formula mass or molecular mass of that substance. All right, then you need to have a balanced chemical equation, because only a balanced equation is going to show you the molar ratios between the 2 substances in your problem. Okay, so now you have the molar ratios. That's conversion factor number 2. The last part is going to be going from moles of substance B into grams of substance B. All right, real important that you have the periodic table handy, and you're going to need to make a second calculation for the molecular mass or formula mass of the second substance. That will allow you to go from moles of B to grams of B. All right, so basically it's 3 conversion factors. First one involves a periodic table. Second one comes from the balanced chemical equation. Third one comes from the periodic table again to go from moles back to grams. All right, watch the video. If that sounded confusing, don't sweat it. Watch the video and it will make a lot more sense at the end, and we'll revisit those 3 conversion factors. Okay, we're going to solve a grams to grams problem. Now this is kind of the big one when it comes to stoichiometry. This is the one that has the most steps. Okay, so you have to pay careful attention. Now just to one-up the situation a little bit, I made a question that, as you can see, it says given the unbalanced reaction. Now because it's unbalanced, we need to step in and balance it before we can do anything that the question is asking. So let's take care of this before we begin. Okay, I see we have 2 hydrogens here and we have 2 hydrogens here. So those 2 sides are balanced with respect to hydrogen. Now here I see oxygen, O2, but only 1 oxygen here. So I need to put a 2 in front, so that way the 2 applies to that oxygen. But it also applies to the hydrogen, making this now 4 hydrogens. So I need to make a 2 here, so that way I have 4 hydrogens on this side as well. All right, so now that we have a balanced equation, let's read the problem. It says, if 22 grams of hydrogen gas is burned in air, how many grams of water will be produced? Okay, this phrase right here, the 22 grams of hydrogen gas, that is the given information. So we call this substance A. How many grams of water? That's what we're looking for. So that's substance B. Now the idea here is we got to go from grams of A to grams of B. You may wonder, well, if we're going to focus on hydrogen and we're going to focus on water, what about the oxygen? Well, it's burned in air, right? And the air has an adequate amount of oxygen. So for the purpose of this problem, all that the phrase burned in air means is that this hydrogen will be consumed, all of it, like all the hydrogen will be used up. There will be no leftover, okay? So that's what that phrase burned in air is implying, that we're going to burn it in an environment with so much oxygen, we're not even going to have to worry about it, okay? All right, so here's the roadmap for doing a grams to grams problem. We start off with grams of substance A. And then from there, we're going to use the periodic table and figure out what the moles of substance A is going to be. Then from here, we're going to use molar ratios, figure out what moles of B is. And then from here, we're going to figure out grams of B. Okay? So that's the general roadmap for how this problem is going to go. And you can see why I said earlier this is one of the bigger kinds of problems because it involves the most steps. So I'm going to write a little smaller than what I was writing with before, okay? A little smaller font, if you will. Okay, so we start off with the given information, which is 22 grams of hydrogen. Now remember, hydrogen is diatomic, so it shows up as H2, not just H. And we're going to need to convert that into moles. So we need to figure out how many grams of hydrogen gas there are for every 1 mole of hydrogen gas. Okay? So anytime you use grams, got to use the periodic table. So 1.01 is the mass of 1 hydrogen. So 2 has to be 2.02, right? Because we're dealing with H2, so we need 2.02 grams here, right? We're basically just taking this number and doubling it, all right? Multiply by 2. All right, fantastic. Got that out of the way. Next step. We have to go from moles to moles, but moles of the hydrogen, which is our substance A, to moles of B, which is water. Okay, now for this we have to look at the balanced chemical equation and figure out what the molar coefficients are. So we have 2 moles of H2 for every 2 moles of H2O. Now you may wonder, why bother? But trust me that it's not always going to work out this way, where you have the same number top and bottom. So as an exercise, make sure that, we can go all the way back to the beginning, that grams of hydrogen cancels with grams of hydrogen, and moles of hydrogen cancels with moles of hydrogen. And you want to keep that practice because you're going to get a problem that's going to have different numbers instead of having them the same. So make sure you put the correct substance in the correct part of the fraction. Okay, finally, to finish this, we've got to go from moles of B to grams of B. So for every 1 mole of water, we have to figure out how many grams of water that is. Now, if you get really good, you should memorize the mass of water because it shows up quite a bit. So here's 1.01, that's our mass of hydrogen, and all the way to the other side in the nonmetal section, you have 16, okay? So the mass of oxygen is 16. So we have H2O, so we're going to need 2 hydrogens and 1 oxygen. Now you can work this out as a little mini problem if you like. All right, so you can make a little calculation on the side here, and then you'll get 18.02 grams per mole of water. All right, and that's the amount we're going to write in here. Okay, so this tells us how many grams there are for 1 mole of water. And again, we put the moles of water from the previous step in the top, but for this step, we put the moles of water in the bottom so that they will cancel each other. And the only unit that remains is grams of water. Okay, so to now work this out, we're going to use a calculator. And what we're going to do is we're going to multiply all the top numbers and divide all the bottom numbers. Remember that the very first part of this, the given information, always starts over 1. So the given information always starts as if it's in the top of a fraction. So here we go, 22 times 1 times 2 times 18.02. Then we're going to divide by 2.02, divide by 2, and divide by 1. Okay, so our final answer becomes 196.3, okay, if I round it up. And that is, of course, grams of water. Now you may say to yourself, man, that is a really big number. I don't know if that's right. Well, you can simply check your work again if you feel like you got the number in error, right, that if you made a mistake. So we can double check that. And divide by 2.02, divide by 2, divide by 1. And we get the same answer. Now, a lot of students are going to get scared when they see a very large number, and you shouldn't be, okay? Sometimes the numbers do work out to be very large numbers, and that's just the way it goes. All right, so you can double check your steps, make sure that everything is canceling, and as long as you have the correct units in the correct positions, then you shouldn't sweat it. If you get a big number, so be it. You got a big number. Okay, that's the steps for solving a grams to grams problem. Good luck, and if you need more practice, then use one of the worksheets and see if you can solve this on your own. All right, you just watched a grams to grams problem. Now that was pretty big, I'm sure. So if it looks like it was a little overwhelming, make sure that you've watched some of the other videos where you're going from moles to moles or grams to moles or moles to grams, something, because this is a very, very intense problem. You need 3 conversion factors to get it right. So step 1, get a periodic table, figure out the formula mass or the molecular mass of the first substance using the periodic table. Okay, add up all the masses, and then that will tell you how many grams are in 1 mole. So that's conversion factor number 1. Conversion factor number 2 comes from a balanced chemical equation. Okay, you need to look at the coefficients of the 2 substances that you're converting between. Okay, and that will allow you to go from moles of A to moles of B. And then finally, you take out the periodic table one more time, and to go from moles of B to grams of B, you need to calculate the molecular mass or the formula mass of the second substance. Okay, figure out how much the grams are for 1 mole of that substance, and then you'll be able to plug that in and find the answer. Okay, so 3 conversion factors, kind of a long problem, and it's also important that you make sure that everything cancels properly. So double check the units and don't be cheap, okay? Don't be cheap. Make sure you write in the units. It's very, very important. Okay, that's all I have for now. Do more practice. Take the worksheet, download it, print it out, and see if you can solve it without the video. Okay, and if you can do that, that's a pretty good sign that you know what you're doing, and then all you need to do is practice and reinforce. Practice and reinforce. Okay? Always check and make sure that you're getting the correct answer. Don't solve a problem without a correct answer, okay? All right, that's kind of a long exit there, but I wanted to include a couple of extra points for you. And if you need more help, watch another video. All right, I'll see you next time.